what your homework actually works properly. So you got all your complex math stuff, because we always had to write in all of our math classes in college all of these math formulas into programs. Anyway, I forgot my water bottle. Alright, so I think we're getting close to actual usefulness. As you can probably see, this vector down here, this texture down here is starting to look like something useful. So we need to do 2 passes on it. We need to do a rough blur pass, and we need to do a fine blur pass, and then convert to world space. But we've already converted everything to world space, so we're good to go. So we just have to do our 2 blur passes, which shouldn't be too hard to do. Alright, so we're going to have a N32 rough blur radius. Let's say 16 pixels. So, rough blur. Or why don't we just do a blur pixels. We'll give it a radius, and we'll say like true on it or whatever, and then like blur pixels with fine blur radius. I'll pass in, because it's the same operation, we're just like skipping some pixel types. Alright, so here we go. Get those 2 going on. And that should be a false. Why don't we just have this be false and this one be true? We'll have it be 32 radius, and we'll blur everything. Why did the colors form a bit of a grid? That doesn't seem like it was showing promising water effects. Well, that's a flow field, right? And then we're gonna blur stuff together. So it's the thing about it is it's not a regular grid. So it's a pretty good candidate for us to actually do some blurs on it and have it all smooth out pretty nicely. And the reason for that is because of the data structure we used for the weighted averages. It has resulted in, the grid squares, because when you look up in the grid squares, they're squares. So the other thing we could do is try we could use a different kind of geometry for that. Like we could use hexes or something, and maybe that would blend better. But we're going to see what we can do with what we got right now. So we'll see. We'll see exactly what we have to do, because if we have to change that geometry, we will. I just don't want to overcomplicate it to begin with. And kind of one of the things that you don't want to do is try to solve problems before you know they're problems. We kind of already did that with the multi-tiered. You know, we put something in there to help with the blurring and weighting, because we knew it was going to be a problem. We just didn't know how much. And once we do the blurs, we're going to know exactly how much it actually is an issue. So again, we'll just do this all stupid like. And 32ay equals y minus radius. Let's see, ay is less than or equal to y plus radius plus ay. If ax is less than 0, or ay is less than 0, ax is greater than or equal to a map width, or a y is greater than or equal to a map.m height, or ax equals ax equals x, and ay equals y. Continue. Alright, so we've got our x and our y, all that stuff. So, got our f vector 2D vec, and our int32, so say this equals 0. Actually, we should just say equals 1. So this will be, let's do our int32 index equals pixels x plus y times m map.m width. Alright, so this, we're going to start off by setting it equal to pixels of index dot pos. Alright, so we're going to add all these together. Alright, so we are going to check right here. So if blur everything equals false, and let's see, pixels sub index dot pos dot particle equals true, or pixels sub index dot path equals true, and we continue. So, and that's going to be basically if blur everything is false and we are either a particle or a path, then early out. Why would a pixel have a position? Because I wrote it as pos instead of direction. It's just a bad name. Alright, so we're just going to do vec plus equals pixels sub. Yeah, I guess we'll just keep doing this. Do we care if it's shore or not, or anything like that? Well, let's just see if we have to worry about shore or anything else. Just try a fine blur. I mean a rough blur and see how it goes. Alright, so otherwise we're just going to do vec divide equal by num and mag divide equal by num. Num is never going to be 0, so we can just normalize it, I guess, and set it. So pixels of index dot pos equals vec, and pixels sub index dot mag equals mag. So I'll have blur pixels on there. Let's just try it with the rough one first, and then we'll add the fine one after that. Is the pixel actually a particle? No. No, the pixel is the actual pixel. The pixel may have been written to by a particle or by a path or something else, but the pixel just contains a magnitude and a direction. And we're not doing the magnitude yet, we're doing the direction first, and then we'll figure out magnitude stuff afterwards. Because when we're going to be in Blueprint Land, we ask this thing like, I need to know which direction I need to go in. It's going to look at its feet, and it's going to say I should go in this direction, and this is the magnitude that I should go in that direction. So if we get the directions proper, then we can start working on the magnitudes, and the magnitude's going to be based on something. I'm not exactly sure, but I'll have to think about it. Alright, so this will be a 16 pixel blur. Let's see what it looks like. So this is just a rough blur, 16 pixels. And see, the grid just, it pretty much vanishes. There's a few little areas where the grid, if you know where the grid was, you'll see it. But the grid squares are not even. So while there is a grid kind of inside of the data, your brain doesn't pick it up because the grid squares are all different sizes. So that's kind of what I was banking on, is that you might be able to see some of this, but you're not like seeing like a tiled texture of, like where you're like, oh, this is obviously just trash. And keep in mind, you're not actually going to be seeing this directly, most likely. You'd be seeing the motion that comes as a result of it. So it's not nearly as straightforward. Okay, so we do this pass, and then now we need to do the find pass. So we'll see how that looks. And as it's doing like a rough pass and then a fine pass, what this is going to do is it's going to blur pretty much the same values with the same values, but it's going to give a different weight to those values based on if they were. We'll see. It might be the wrong order of things. I might need to blur it all in the same pass and just have like a multiplicative weight on top of the path or the other ones, but we'll see. I just wanted to weight kind of the blur radius differently. So here we are. This is our flow field then. Have I played World of Warcraft? I played like for 2 months before I went to college and never played it again. So I think the highest I ever got was like a level something assassin character. I didn't really play that much. I think we lost a little bit with that final blur pass, but I think it's in the right vein. So I think what I need to do is maybe make these things parameterized so I can actually do stuff with it. Alright, so we're going to need the generate flow field stuff. Yeah, I think the most MMO stuff I played was, I played a bunch of Star Trek Online, I played a bunch of Aeon at one point, and I played a bunch of Age of Conan at one point. I think Star Trek Online was the better of those games. Age of Conan was just hilarious because of how freaking broken it was. Like, you'd spawn into places in the map and then you'd fall through the floor. And Aeon was fun for a while, but I don't know, it just got freaking tedious. And I think I like Star Trek Online because I like Star Trek. And because you could play as like the assault class ship, like the Defiant, and then you could basically just hit all the buttons and your ship would fly super fast, and you got the ramming speed thing ability at one point. So what you do is you'd hit all the buttons to make your character go, your ship fly as fast as possible, and then you just ram into the enemy ship and just blow everything up. Yeah, flying in Aeon was, what they had the Abyss and all that crap. That was their whole thing, was this big PvP area where you could fly around and kill people. The flying stuff just turned into a giant pain in the ass. Like, it should have been a super fun thing you should have been able to do all the time, but that's not what happened. Like, there was so many limits on flying that it was just annoying. And I guess they did that because, you could like kite people around and shit like that, where you'd be like, oh, well, I'm going to fly over here and, it's going to take 2 million years to actually catch me. It's just like, well, Alright, so we're going to want options for generating our flow field. So we're going to do like shore radius. We've got a lot of stuff that we want. So I guess we should probably just have set variables or something on here. And we should have some sort of function that you call to set everything. This will be like set flow field gen variables. So we're going to have float shore edge magnitude, float and max magnitude, and 32 and shore radius. Is there already a shore radius and all that? No. Yeah, I think, like, God, I can't remember exactly, but like Age of Conan also had water stuff, and World of Warcraft had water stuff, and it was just, I don't know. They did fishing right, but like swimming around in water is always just ridiculous. Age of Conan's was okay, but and this shouldn't be edge magnitude, this should be edge weight. Alright, we'll divide these out by particle weight, tiered average weight, float, rough blur, tiered average weight. Okay, so in 32, rough blur radius, 32 fine blur radius. Okay, so these should be our variables then. Yeah, depth perception is always an issue. Might be better in VR. Probably the opposite. You just get everybody sick in VR. Though I guess flying is one of those things that actually does work properly in VR. People don't throw up all over the place. Like piloting spaceships and all that stuff, actually, your brain doesn't get all confused. I mean, it gets confused, but it doesn't get so confused that it just like vomits all over itself. So set some defaults for all these variables. Max magnitude, we had at 10, shore radius at 10, blur radius at 16, fine blur radius at 16, shore weight, these were all 1s. So let's get all this in here. SAO the Matrix VR, yes. I don't know, I'm just... New stuff has been coming out so often, all the time, forever and ever, that I just don't pay attention to anything until it actually comes out. Because there's been so much stuff that's been hyped over the years that I just don't care anymore. Like the Wii came out, everybody's like, oh my god, motion controls are the future. And then like one generation later, nobody has motion controls in anything. I just want to sit in my couch and have a needle shoved in the back of my brain. That seems like a fun time. Well, we'll get there eventually. And the fight for that is going to be led by the pornography industry, so just keep tabs on that and I'm sure you won't miss it. Alright, so that should write all of our stuff out here. So let's go to our generator and then actually start using all these values. Our short radius is going to be the short radius here. Path magnitude. Alright, path magnitude. Path flow weight? Is that what I had? I guess so. Particle weight. This will be our tiered average weight. Want our rough blur radius. And then our fine blur radius. Alright, so we should be able to compile that, then go change our blueprint to actually call this set flow field gen variables. And we can like expose all those variables so we can play with them at runtime here and keep calling generate and see what we can get out of it. So we'll see. I don't know, it's one of those things I think in a lot of games, like if you've got cool stuff like flying or whatever, somehow games have, it just kind of happens. They'll take the cool thing about their game and they'll turn it into the thing that is the most difficult to do and therefore makes the game really frustrating. Like early on in the development for Dashkin, I remember back at like EA2D when it was like Adam was sitting down talking to this guy Mark Spenner, who is the VP for our area, and it was talking about Dashkin, and he's showing off the early prototype, and the character runs super fast, and it's kind of a very much a speed-based game at that point, where it was very much just all time trials and everything else that was the real design. Alright, so let's get a new speed, crop, blur, radius. This should be inside of flow field jet. And one of the things was, it was really fun to run super fast and have Whitey turn into, his like super fast running animation where he looks, no longer like himself, but looks more like where he would look more like this, where he's super fast and everything like that. You'd be flying along super quick in the browser and Flash and everything. It looked really cool, and as soon as you did this, though, like, you couldn't see where the hell you were going in the game, and you'd immediately slam into a rock and die. And it's basically sitting down and talking about it, and like, how are we going to make this thing, this is the most fun part of the game, is going this fast, but then, of course, when you go that fast, you're at your most vulnerable point, so you never want to do the thing that is the most fun thing in the entire game, because if you do, you're going to die. Unless you've memorized the entire level and you know exactly when to jump and everything like that, in which case it's kind of like, well, you've already, the super fun part of the game at that point is your memorization, not necessarily the experience of going super fast or something like that. Is you kind of lose it. All your new players can't do the fun thing and get all pissed off and then leave. This is kind of the same thing with like flying and Aeon and all that. And, like, they have the super fun thing that they want to be the overriding factor in their game, and then all of a sudden, oh no, you can't do that, because reasons. Okay, so we need to make all these variables exposed, and then we need to call all that when we generate. So I need, alright, so we need a float in here. It's gonna be max flow mag. This will be a float. This is the maximum speed for flow. So what's your plan to fix that? Well, wouldn't you like to know? Well, it's not, the game is not just simply time trial and stuff like that. That's a big one there. We can actually zoom the camera in and out and all sorts of stuff like that, which you couldn't do back in Flash in the day. There just wasn't enough processing power if you're going to maintain 60 FPS. So we can do a lot. And, we're using a perspective camera and everything like that. So, but the problem still exists, but the game is going to have a lot more than just, I'm going super fast time trial, because we can do a lot more, because we're not basically shackled to Flash and shackled to the browser, where having 60 FPS is just really damned hard to do. Because, it's a browser, you don't have any control over it. Alright, so flow magnitude, okay, so we want the shore radius. So, this is how far the shore repels objects in the flow field. And that's going to be a default of 10. And we're going to put that as a 1 to 20 is like a slider. Alright, so we have the rough blur, the roughed blur radius, this rough blur radius. Rough blur radius is going to be 16. We'll do a, 0 to blah. Fine blur radius. And what our descriptions, this is how big the second pass blur is. I don't know, some of this is just going to be Greek. This is how big the blur, the first pass blur is in pix. So the fine one I'm going to put down to like 8, and this will be from 0 to, again, 32. Fine blur radius, rough blur radius, shore edge weight is what we need next. Alright, so this is how strong the shore avoidance is in the flow field. Maybe I should spell field properly. So it's going to start at 1 and we'll go to like 10. And this is going to be the path flow weight. This is how strong the path follow weight is for the flow field. 1 to 10. This is particle flow weight. This is how strong the flow field follows particles that are simulated. Then we need the tiered average weight. This is how strong the average weight is. It'll be 0, 1 and all that stuff. Alright, let's see. We want to then generate flow field. We want to actually set all of our variables. It's called setup flow field gen variables. Alright, we're getting there. Yeah, I was more pointing out that example earlier. It's just something that it's very easy to accidentally, like, sometimes the game, as you keep working on it, becomes less fun. Like, you start adding a whole bunch more stuff on top of it, and all of a sudden, like, the game falls apart because you took away that which made the thing actually fun somehow in the process of making the game. And it's a very easy thing to do, which is why it's important. Like, you know, why do we have QA focus testers and stuff like that? Because, you know, they can see things that your lead designer can't. And why is that? Because it's usually their first time messing around with the game, so they don't have any biases built in as to what should happen. So it's kind of one of the things with, like, I'd say platformers are a good example, where you can make something so incredibly hard that nobody can actually play it, except for like a certain class of individual who knows everything about platformers. So if you've got a genre where everybody understands all the rules, you can make a super complex game and have it work real well. But nobody will be able to enter the genre because your game is too damn complex. Alright, so we'll get there, we'll save all this stuff, and what I need to do is unhard code the levels in this for the weighted average. Say that to Dwarf Fortress players? Hello, the Jalmega. I'm sorry, I don't play Dwarf Fortress. I play Microsoft Excel, the game, and that's how I play Dwarf Fortress, because playing the actual game is it's not about that. It's about pivot tables. Let's be honest. Like I've sat down and played. I've played Dwarf Fortress before. I consider myself a non-expert on that game, but I knew enough to actually like pull up all the tools and all that stuff, and I was able to survive for quite a while and have my dwarves slowly go insane and all that stuff. Alright, the Jalmega, you have a good one. Alright, so I need to get which power of 2 this object is. Also, hello Kento 456. I'm working on just messing around with some of the flow field. I've got it generated. I don't have the velocities at every pixel yet. I'm working on getting the direction proper. And this is kind of funny. I find myself thinking that I should already know the answer to this, but I just want to know, like, I've got this m width, and I want to know just how many times 2 goes into it in code, and it's like, well, I want the log base 2 of this integer? So, I mean, I guess the answer to that is the bit, like, the leftmost bit index on that thing. But is there a way to do that without doing some sort of stupid crap? I mean, you know, I could do like while num divided by 2, you know, is like greater than 0 and shit like that. But, you know, is there like some function that already does this, or some trick I should already know that actually does this sort of thing? Because I feel like after programming for so long, like powers of 2 stuff should be just like, well, you just shift this other thing or whatever, and I just want to get like the level of this thing and then subtract a couple things. So like, you know, if we're at 512, I just want to like, I want to get, you know, the number that it would be to go to 0, and then I just want to like subtract 3 from it or whatever, and get, you know, like, well, you know, we could go out to 8, but we only want 5. I guess I could just check or something like that. It seems really funny to me that I don't see a super easy function that's just off the shelf that's like, you know, fmath, you know, like log base 2? Is that just computes the base 2 logarithm of the specified value? So we can just do mmap.mwidth, and we'll do like fmath like floor to int. So int32 max levels equals that. Then we just say like max levels minus equal 3. And it's basically like, yeah, if max levels is greater than 3, then we'll minus equal 3. Is that gonna work? I don't know. Whatever. Let's make sure it actually does what the hell I think it does. Alright, well, let's see what it looks like. Alright, so we got all of our flow field generator stuff going on. So we'll tick our flow field. Then we should be able to call generate flow field. Then we should be able to call generate over and over again with different variables, I believe. Unless the construction is going to get called, in which case I guess that's not the case. Two, 3, 4, 5, 6, 7, 8, 9. Oh my god, just get rid of this crap. This will be 1, 2, 3, 4, 5, 6, 7, 8, 9 should be the value of this thing for max levels. See what it actually is returning. I think the development build is lying to me on some of this. Good evening, Adam. You gonna start streaming here sometime? Is that the plan? I'm just messing around with the flow field stuff right now. Back to actual work. Because this is what it looks like at the moment, and we're just messing around with some of the parameters for it. Flow fields are the best fields. Could be true. So what you're looking at right now is the direction baked into the texture. So a direction of blue is kind of bottom left, like you can kind of see it. Like green is kind of, you know, down and to the right, and then, you know, as it gets more yellow, it's going towards that thing. So these values here are kind of, you can kind of see on these rocks and everything where it would go. Max level is 5. Okay, cool. So I'm thinking that looks halfway decent for the direction stuff. This stuff is not super amazingly amazing, but it's not awful either. Alright, so probably the next thing that I need to work on is I need to work on the actual, how to get the magnitude of this working properly. So I'll be right back and I'll start working on that. So what I need to do is I need to figure out how the magnitude of the flow field stuff is going to actually work, because that's all our particles that we've got for this thing. So the directions, I think we got the directions pretty well dealt with. The question is going to be, what should the magnitude be? Now, one thing we could do is just take the magnitude as the number of particles and just like slap that on top as like, you know, screw everything else. The magnitude of the flow field is just like the particle density. But that's probably not the best thing in the world because, you know, the particle density, I mean, it's pretty close. Like, particle density is close. There's just problems over here. Because if we took the particle density and we blurred the hell out of it, we'd have problems over here. There wouldn't be much magnitude, you know, getting us away from this thing. We could take particle density and we could take the geometry that we've got here for our objects. Like, we could take our inputs and outputs and we could write into that. Is magnitude the velocity? Yes, magnitude would be the velocity. So like, we've got our directions that the water should travel pretty much, or something on the water should be traveling in that direction. Now we want to know how fast it's supposed to be going. And there is some speed stuff baked in here, but sometimes it's better to have things a little bit disconnected, just because then your eye can't as easily pick out the pattern that is causing said thing. The opposite argument would be, if they're not the exact same, then weird things could happen. But I'm thinking at this point, particle density blurred out might be a better plan, because what it would have is these things wouldn't be moving at all. The shadows of these rocks actually cause less flow.